All right. Well, hello again. So, what these are basically like an extension of your chapter 21 activity you started last class. So just a reminder that you were given predicted values for about whether you could roll your tongue and if you have attached your lobes. If I look like I'm wearing the same outfit, it's because I am, because I'm making these all on Friday. So enjoy that. You don't actually need to see my face for this. I'm actually just going to close out. Okay, so this is a different type of chi-square test. So a chi-square test for independence is if you're given a two-way table. Literally, it's just if you're not given predicted values. So this is the only time you have to use it. It's a slightly different version of a chi-square test, but again, it's if you're given values, but you're given them in a two-way table, and you're not given your predicted values. So this would be like if you tried to research something and you couldn't find what the values should expect to be, you could actually just see if there's a connection between two categorical variables. So again, this is categorical data. Okay, significance level, just a reminder. For these, we're always going to use 5%, so you don't actually have to do anything with that besides looking at the 5%. This is what we're used to seeing, and that's how you tell whether you're going to reject your null hypothesis or not. Okay, the null hypothesis, it's nice because it's the same for all of these. It's that the variables are independent. You want to be more specific and say what the variables are, but then the alternative is just that they're not independent, which is pretty interesting. So there's not a whole lot you have to write for those, and then your degrees of freedom is the new part. So your degrees of freedom for a two-way table is rows minus 1 times columns minus 1. So this first little section here is going to be super useful. You can use this paper on assessments, so have it handy. If you want to print it, it's probably a good idea. If you don't have a printer, just make sure you save it in a nice little spot for yourself. Okay, expected values. Because you're not given predicted outcomes, you have to do your row total for your independence times columns divided by grand total. I know that probably makes no sense yet because we haven't seen an example yet, but this part right here is actually the same as what you did with your ear and tongue lab, okay? Your calculated, your chi-square calculated, we're going to do together. The critical value, you can either get from your graphing calculator, or if you end up taking stats again in college, this is the second page of these notes, and this is what you would use. So we're going to go through how to use this in a little bit, but for now, you want to do that. And then you also, this is actually, I want you to do both. I want you to also compare your p-value to the significance level. Again, the significance level is 5%. So you're trying to see whether your p-value is less than 0.05 or not. Okay, moving on. Critical values. So you use the table that I showed you, or you can use your graphing calculator. The chi-squared calculated is the same formula that you guys had before. So that's not going to be new, but how we get the expected value is new. So that's the big difference. And then again, if your chi-square calculated is greater than your chi-square critical, you reject. But also because if your p-value is less than 0.05, you reject, okay? And by rejecting a null hypothesis, in this case, if you're saying the two variables are not independent, that means that they're dependent, which means that there's some kind of connection between them, okay? So the example that we're going to do is based off of what level of schooling you're at. So I'm going to call this level. And you're going to compare it to your grade that you get in each level. You probably have an idea of what the answer is going to be for this, but we're going to test it to see which one is true. Whoopsie. I don't know what that was. I don't want that to be here. Go away. Okay. Sorry, I don't know why I sing things. It's weird. Okay. So we're going to try to see if there's a connection between your grade that you would get versus the level of education you're at. Okay. What I want you to do first, just to make this easier on us, is figure out all the totals here. So pause the video. I'm going to have you just literally tally this up, do totals for each, and then you're going to do your grand total, which is the total of the totals. Alrighty, so hopefully you got these totals: 300, 330, 110, 290, 200, 250, and then the grand total is 740. So that's going to come in really handy later. Then we are going to state our null hypothesis. So this is where you want to get pretty specific. You want to say that your HO your null hypothesis equals that your grade level, you could just say actually level of education, it's probably easier, and grade are independent. Okay, so that's your null. And then your alternate, this is super similar. You can actually just copy what you had. Sorry for this. So your HA, oops, is, you can do one of these where it's like the same. So level of education and grade are not independent. Whoops. Okay, so that's your null and your alternate. Okay, degrees of freedom. Just a reminder, you want to do your row -1 times columns -1. So in this case, again, this is different than what we did in our lab last class, so that's why it's a slightly different formula, but it's also above if you need to look at it. So the number of rows we have is 3, right? So if you look at your table, you have 1, 2, 3, -1, times your columns -1, and you have 3 columns as well, so it's 3 -1. So you end up with 2 times 2, which is 4. So your degrees of freedom are 4. Your chi-square critical value, again, you can get from your table on the back. So I'm going to just show you how to use that. You'll also be able to use a graphing calculator to do this if you don't want to use the table. Some people like the table because it's very familiar to what they do in college, but it's up to you. I'm just going to show you both methods. So for your chi-square critical, you want to look for 95%. So this is always the column that you want to look at. This is on the back of your paper, just so you know, or your second page. And then you look for your degrees of freedom. So we would go over to 4, slide to 95%, which is usually our confidence level, hence where you get it from, because it's technically your critical value is 5%. So our chi-squared critical, which means it's like what you expect things to be basically, is 9.488. That same number is in the table that I gave you guys on your lab that we did last class or 2 classes ago. So either method, if you find it easier just to look at the table I gave you in the lab, that's fine too. It's the same numbers. But that means we need to use 9.488 as our critical value. 9.488. Sorry, I'm like out of breath from sitting and speaking. My belly is getting large. Okay. So find the expected frequency. In order to do that, we're going to show one of these cells by hand, and then the rest I'm going to have you do in the graphing calculator. So what we're going to do is literally just copy over the information from the table above. So you're basically going to recreate the table, but I'm going to show you how to find each value individually by hand. And then we're going to just do it in the graphing calculator so you can see how it works. Okay, I'm actually going to do this on the next page because it'll be easier for you to see. So we're going to make a table. We're going to make it a 3 by 3 because that's what we're given. But then so I can have titles, I'm going to make mine a 4 by 4. Okay, So this is elementary. This is junior high. This is senior high. Oops. Go into your home. Okay. A or B. C. Oh, go in the box. Sorry. I get very impatient with technology sometimes. No. Okay, C. And then this is D or F. Of course, that one worked. Okay, so let's do the first one by hand. And then again, I'll show you in your graphing calculator how to do the rest. So just a reminder that when you try to figure out each expected value, what you're really doing is doing your row total times your column total divided by your grand total. So the row total for an A or B, if you look back at your table that you have, was 300. Then I have to multiply by the column total. So that means I need to look for all the elementary school students. So that was 290. And finally, I need to divide by my grand total, which was 740. Okay, so that's how you get the first number. Just so you know, that comes out to be approximately 117.57-ish. Which if you look back at the original table, it was 100. So we're pretty close, okay? Now, the rest of this, I'm actually gonna have you do in your graphing calculator. And if you have not taken pre-calc, this is gonna be super new to you because you've never learned matrices, most likely. So in your graphing calculator, you're going to go to matrices because if you look at a two-way table, it looks like a matrix. If you're not familiar with what a matrix is, it looks like a two-way table. So either way, you're good to go. Okay, so what we're gonna do is we're gonna go to second matrix, which is blue, but it's also with the little x to the -1, okay? We're gonna enter in our observed table. So I need to go over to edit. I also need to tell it what size matrix it is, so what size table. It is a 3x3 table, right? Because I was given 3 values for rows and 3 values for columns. My first number was 100, so you start typing in. If you hit enter or tab, it should go over. Mine is not for some reason. Weird. Come on. There we go. Enter will let you slide over to the next one. And then we have 80 is the next value to the right. And then 120. You don't even need to do the totals, which is nice because it'll do it for you eventually. Hit enter again. Then we have 130. Then we have 90. 110. 60. 30. 20. Okay. So what's nice is once you have your data in a matrix, this remember this is only for a two-way table, 2x2, or just a two-way table, not 2x2. You actually don't have to do the workout necessarily. I am probably in your next set of notes just going to have you try a few by hand just so you can remember how it works. But the nice thing is if you just hit quit, so go back to your main screen. Now you can do a chi-square test. Last time we went to stat tests and you guys chose goodness of fit. Now, if I don't have my data in L1 and L2, I don't need that. I can just do a chi-square test because it assumes that you have your data in a matrix A. So you want to choose chi-square test without the goodness of fit part, okay? The nice thing is you don't even need your expected data in here because it'll do it for you. It'll actually insert your expected values in for part B, for matrix B. And I'll show you how to get that in a sec. We now just want to go to calculate. Ooh, convenient. This is our chi-square calculated value. So it's 20.6. Let's write that down. 20.6. So that is here. So your chi-square, and chi looks like an X. It's kind of like a curly X, but your chi-square calculated, which is the one that comes from your data. What did I say it was? 20.6. And we'll use that information in a second. Then my expected frequencies, you want to actually make the table here and we want to plug it in. So I'll actually like type them in on this chart in a second. I just want the numbers. I don't even need the work anymore, which is convenient. I can do that now by just looking back in my calculator. So if I go back into the matrix, oh, this is another good thing to write down. Sorry. This, just so you know, is 3.7 times 10 to the negative fourth, which is literally 0.0004 if you round the 3.7. So let's actually write that first. Sorry, I'm skipping a little. So that was P equals 0.0004. Super important because eventually it'll help us figure out whether we reject our null hypothesis. Okay, back to our expected frequencies. So we're on number 4 still technically, even though we've gotten a lot of information. Now, our expected table you basically want to redo. So I'm just gonna have the answer here and not the work anymore so that it's easier for us. So it was 117.57 for the first one. What you'll see in your calculator is if you go back into your matrix, you'll go back into matrix, go to edit, but scroll down to matrix B. And what you'll see is your expected table. So it did all the math for you. So now all you have to do is literally copy these numbers down. Okay, so I would pause the video at this point, or technically it should be on your graphing calculator too, so you could just copy it over. But these are your expected values. Notice that the 117.57 matched what we did by hand. So if I ever say to find that by hand, remember it was row total times column total over grand total, okay? But you're gonna fill that in here. Our last step is just gonna be to figure out what these numbers mean. So if you look at your chi-square critical value, it's 9.5-ish. Your chi-square calculated was 20.6. So I want you to look back at the top, because if your chi-square calculated is greater than your chi-square critical, which ours is like way higher, 20.6 is greater, way greater than the 9, it has you reject your null hypothesis. The other reason I'm rejecting is because look at your p-value. It's way less than 0.05. So either way, when you figure out what this means, your final answer is going to be to say, we are going to reject, and you can just draw like an arrow to this. You can reject your null hypothesis. Oops. Because P is less than 0.05. And so there's actually 2 reasons. And because if you want to write out the words, a chi-square is what this looks like. Your chi-squared calculated is greater than your chi-square critical. Okay, so just you want to do both of those to verify. Technically, you can always use your matrix and turn it into a table like we did with the first way we solved. But I find it easier with a 2-way table just to use the matrix feature. So there are a few different ways. If I ever ask you to show it by hand, I just mean your expected values. But what's nice about this version is you don't really actually have to make a lot more work for yourself. Just know that this formula would be if you listed all of these out vertically, And then you did your observed minus your expected and so on. So I'm not going to show that because you're only going to have to do that with tables. All right, that's it, folks. Have a wonderful rest of your day or life, as my husband said.